So let us do this integral. Now, in order to do this integral, we can simply first write I as the name of the integral. This is just a customary thing that I do in all of my integrals, and I'm sure you do as well. So e to the power minus 2025x minus cos of x by x. Notice that while doing this integral, you cannot directly use certain methods, like you cannot include a minus 1 and a plus 1 and then deal with the integrals separately because of convergence issues. So those things have to be kept in mind, that this is not a limit, it's rather a definite integration. So the method which we are going to use today is again similar to Freeman's trick, but rather in a more sophisticated way. So what I'm going to do is this. Note that 1 by x can be written as 0 to infinity e to the power minus of dx dx. Now, while trying dt, right? Sorry, e to the power minus dx dt. This will produce 1 by x as a coefficient if we treat x as a constant here. Now, notice that what we are going to do is we are going to replace this dx by x here. So the 1 by x will be represented as this new integral, and we would be trying to apply iterated integrals in order to solve this. So notice how I write this: 0 to infinity e to the power minus 2025x minus cos x. And with this in hand, the 1 by x, I can now simply write this as 0 to infinity e to the power minus dx dt, and then there is a dx at the end. Okay, let's say this is the integral in question. Pardon me for the brackets. Yeah, okay. So now, using Fubini's theorem, we can interchange the integral, and this is also supported. It is not really very that easy to verify, but I have verified that it is supported. So we can in fact write this as e to the power minus 2025x minus cos x multiplied by e to the power minus dx. And now the inner integral, right now we want to do the inner integral in terms of dx first, and then we want to do dt. So this is what I mean when I say interchange of integrals. It is not always valid, so remember that in mind. I might make another video about the validity of this, which is a much more interesting topic than this one, at least to me. But yeah, the integral might seem more interesting to you as well, because, well, it's a very curious integral as we are using this iterated properties, right? So 0 to infinity. Now, inside we can break this into two different integrals because both of them exist separately. So this one becomes minus of 2025 plus t into x, and this one exists as e to the power minus dx cos x, and this is basically dx, and this is also dx, and I want to write it as a separate integral, and then I want to close the bracket and simply write a dt here. Okay, now 0 to infinity the outer integral, and now inside this first integral is nothing but 1 by 2025 plus t, right? 1 by 2025 plus t. And the other integral, this we have done a lot of times. This is nothing but, see, in this kind of e to the power minus ax sin x integrals, so sin x and cos x, both of them can be done. So in this case, this is cos x. So that is why we will simply have t by t square plus 1. And now we will have a dt here. Now again, this cannot be evaluated directly. So what we are going to do is we are again going to write it as a limit. Limit a tends to infinity, 0 to a. And now we are going to evaluate this integral, which is 1 by 2025 plus t minus t by t square plus 1 dt. Correct? Now, notice that while doing this, we can simply write this as limit a tends to infinity, and this becomes 0 to a. So let me not write the integral. So 1 by 2025 plus t can be written as ln of t plus 2025. And I want to do this from a to 0, right? And this one can be written as half ln of t square plus 1. And again, I want to do this one as well from the limits a to 0, and everything is inside the limit. Okay. This would give me limit a tends to infinity. So give a big bracket outside and do this. So this would become, obviously, if you put a and then put 0, it simply becomes a plus 2025 divided by 2025, right? 2025 minus half Now again, if you do this, this becomes a square plus 1 minus, when you put 0, it becomes ln of 1, which is 0. So this is nothing but ln of a square plus 1, right? So we are clear on this one. Now, separate the part which is the integral part, which means we can write this like this: ln of a plus 2025 minus half into ln of a square plus 1 minus ln of 2025. This is what we can write. This is our final answer, kind of. So the first two expressions are part of the limit. So let me write it like this: limit a tends to infinity, ln of a plus 2025, and this is basically dividing it by root over of a square plus 1. And outside the limit, we have ln of 2025. Since this goes to 1 because of this limit, you can simply write this as ln of limit. So ln of limit a tends to infinity. This becomes 1 plus 2025 by a if you divide up and down by a, and this becomes root over 1 plus 1 by a square minus ln of 2025, and therefore this becomes ln of 1 minus ln of 2025, and the final answer is 0 minus ln of 2025, or you can simply say the answer is log base c of 2025, which is our correct answer. So I hope this method was understandable, how we use this 1 by x to write it as 0 to infinity e to the power minus px, and then use this integral, interchange the integrals, finally get an expression which we have to evaluate in terms of a limit. Otherwise, this is going to diverge. Both of the integrals will diverge if done separately. Okay, 0 to infinity this and 0 to infinity this separately diverges, which is why we would rather like to do it using limits to find out the limiting value and finally reach the conclusion that the answer is minus ln of 2025. So that would complete the question. I hope you like the solution. Let me know in the comment section if there are any queries. Thank you.